Left off and we were just talking about antiderivatives. So I told you an antiderivative is the opposite of a derivative. So eventually we're going to call this process integration. So calculus is divided into those two topics. So derivatives, which we're going to continue to do for the rest of the semester, and then second semester we're going to do antiderivatives or integration. Okay. So we're going to introduce the topic now. So we did a little bit at the end of class last time, and we left off with the question. It says, what is the antiderivative of f of x equals 2x? So what do I take the derivative of in order to get 2x out? Yeah.
X squared plus c.
X squared plus c. Good, you remember the c. So in order to write the antiderivative of f of x, since we don't have like f prime and going back to f of x, if you ever have like an f of x, g of x, whatever, and you want to show you've taken an antiderivative, we do a capital F. Are you with me? So capital F of x equals x squared. But it could be x squared plus 7, x squared minus 5, and so on. So we do x squared plus c.
Is it always a capital F?
Yeah, if you start out with like a lowercase and you're trying to go backwards, you would do a capital F.
Okay, so even if it's g of x or...
Yeah, you would just do capital G. Yep, exactly. All right, so it says if f is an antiderivative, then the most general antiderivative of capital F is capital F of x, and then don't forget your plus c. Okay, I remember taking a calculus exam when I was in high school, and I left off the plus c on every single problem. It was sad. All right, so find the most general antiderivative of each of the following functions. So if I have cosine of x, so again, we're thinking, what do I take the derivative of in order to get cosine of x out? Sine of x, exactly. So I should have capital F of x equals sine of x. But it could be anything. It could be sine of x plus 1, sine of x minus 100. I don't know. So we put sine of x plus c. Because when I take the derivative of a constant, I'm going to get that 0 out. Does that make sense? Okay. So how about if I have sine of x? Yeah, it's negative cosine. A little bit tricky, right? You really have to have those derivatives down, don't you? So it's going to be really confusing when I give you a derivatives drill. All of your faces. You're like, wait, what? You all think it's now. I'm not going to do it now. But if I give you a derivatives drill and you've been working on antiderivatives, it can be very confusing. So yes, this ends up being negative cosine of x plus c. Exactly. All right, so what's our general form? So if I had like x to the 5th as my derivative, how do I go back to the antiderivative? I need to have x to what power, first of all? To the 6. What do you think is going to be out front? Yeah.
1/6.
Yeah, 1/6. Do you guys see that? Because if I had 1/6 x to the 6th, when I take the derivative of it, the 6 goes with the 1/6. 1/6 times 6, and then I drop my power by 1, right? So it becomes x to the 5th. Does that make sense? We know that if we had y equals 1/6 x to the 6th, its derivative is 1/6 times 6, so 1 x to the 5th. Okay, so what's our rule? So if I have x to the n like this, yeah, it's going to be 1 over, not just n, 1 over n plus 1, right? And then x raised to the n plus 1, and then on the end just plus c. So Adam, do you have a question on that?
No, I'm going to tell you what he said.
Oh, okay.
Sorry.
So 1 over n plus 1, x to the n plus 1, and then plus c. Yeah.
Why couldn't it just be n plus 1 on the outside instead of x? Because then it would just be like if it was 5x to the 6th.
Yeah, so I think you're thinking of derivative when you pull it out. So if you have x to the 7th, its derivative, I agree, is 7x to the 6th, like that. But if we're going backwards, so if I had x to the 7th and I'm doing its antiderivative, I would need something that has x to the 8th. And I need to undo the part where I pulled the power to the front, right? So I need a 1 over 8 so that when I pull the 8 down to take a derivative, 8 times 1/8 goes away. Does that make sense? Okay, so on the next part, so I have x to the negative 4. So we're going to use this new rule, and we're going to say, okay, add 1 to the power. So negative 4 plus 1 is negative 3, and I do 1 over that new power. So 1 over negative 3. And then I do a plus c. So you can clean it up if you want to. It would be 1 over negative 3x cubed, and then plus c. All right. Lots of music from the French room. All right, so the next one. So I'm going to do g of x equals. So I remember when I was in high school, I had trouble with this. I really had to think about it. And a lot of times it requires you to be pretty good with fractions. And I think some of you guys still have your fraction phobia left over from like middle school, elementary school. So if you need to do it one piece at a time, that's fine. So what I did is I would always write the 5 And then I would just think about my x the fourth. So if I was just taking the antiderivative of x the fourth, it's going to be 1/5 x the fifth. Do you guys agree? See where that comes from? And then I have minus, so what do I take the derivative of in order to get minus 6? 6x, exactly, and then plus c. And then I just take care of that 5 and 1/5. So that way I wasn't like doing it all in my head. I could kind of do one piece at a time, and I had that kind of straightforward method. So you can do that, or if you like to do it all at once, that's fine. So you'd be like, okay, I'm going to have 5 and then times 1/5, so that's going to be 1. Does that make sense? So like on this next one, when I was in school, I had to write it as capital F of x equals, and I'd think, okay, I have my 3, and then I have 1/5 x the fifth, and then I have my 2, and then I have my 1/4 x the fourth, and then I have my minus 5x and my plus c. So your antiderivative should look like 3/5 x the fifth plus 1/2 x the fourth minus 5x plus c. Does that make sense? Okay, so do you guys want to try the ones that are on your homework really quickly? We're going to do those really quickly.